Okay, good news. We have a formula, not for n by n matrices, but for the inverse of 2 by 2 matrices, which means we do not need to go through all that trouble of row operations in order to find the inverse of any 2 by 2 matrix. Let's test this formula out on this problem. We're asked to find the inverse of matrix A, which is equal to 2 down below 1, negative 3 down below 1. Okay, solution. We are going to use our formula. When A is A down below B, C down below D, then that implies that A inverse is the fraction 1 over cross product minus cross product. A times D minus B times C. You see where we got the denominator? Cross product minus cross product times, now we're going to take the original A matrix, we're going to swap the corner entries A and D. So now we have D in the upper corner and A in the bottom corner. See how we switch them around? And we're not going to swap the other diagonal. Instead, we're just going to change the sign on the other diagonal. Negative B down below and a negative C up above. That is our formula. 1 over, so all you have is the original A. The A inverse is equal to 1 over cross product minus cross product. Cross product minus cross product in the denominator, times this new matrix formed by swapping the diagonals A and D and not swapping the other diagonals, just changing the signs. Okay, now it works. You can test it and see that it works. Let's go ahead and try to use it. Thus, A inverse for this problem, which we had A equals 2 down below 1, negative 3 down below 1, A inverse is equal to 1 over cross product 2 times 1 minus cross product 1 times negative 3 times the matrix where we swap the 1 and the 2, and then we do not swap the other diagonal, we just change the signs on the entries on the other diagonal. So we swapped the 1 and the 2, we didn't swap the negative 1 and the 3. We kept them where they were and just changed their signs. Now let's simplify the denominator of the fraction that's out in front. Remember, the number out in front is just a fraction. It's a scalar. It's not a matrix. So we get 2 minus a minus 3 on the bottom. So it's 2 plus 3. We have 1 over 5. 1/5 times 1 down below negative 1, 3 down below 2. And then we can go ahead if we'd like and distribute the multiplication of the scalar 1/5 throughout all the entries. So we see that our inverse, A inverse, is the matrix 1/5 down below negative 1/5 and 3/5 down below 2/5. Of course, if it was necessary, we would simplify each of those fractions. We always simplify our fractions. Now you can check to make sure this is a good solution by doing the check of A inverse times A should give you identity, and A times A inverse should give you identity on both sides. Do the multiplication to demonstrate that your solution is good. You can even check it yourself when you're doing your test to make sure your answer is good.